I've created what I feel is the best way to create full stack Web3 applications in 2023 and beyond. I've packaged it all up into a kind of boilerplate project that you can clone using a CLI tool. And in this video, I'll show you everything that you need to get started. The tool that I'm going to be showing you today is called EVM Kit. And it includes all of the pieces of the puzzle when it comes to creating full stack Web3 applications. So everything that you would expect in a smart contract environment, like the creation of the smart contracts, the testing of the smart contracts, deploying those smart contracts to local nodes, test nets, mainnets, and that works for all EVM chains, as you can see on the homepage here. This is going to work for environments like Ethereum in the testnet and the mainnet environment, chains like Polygon, really any blockchain that is EVM compatible, which is around 700 or 800 chains right now. After you're happy with your smart contract environment, you will move into the other half of the repo, which is the application side of things. As you can see in this bottom section here, we're going to be using Next.js, we'll be using TypeScript, Tailwind CSS for the styling of the application, as well as a UI library called shadcn UI. I know that's a mouthful, but it is a really powerful UI library that is fully customizable, and I'll show you a quick little demo shortly. The last little note here is all of the quote unquote batteries, as you can see here, is provided. So you'll get things like the RPC endpoints out of the box for all of the EVM compatible chains. You will get the availability of thirdweb's IPFS pinning services out of the box, as well as the infrastructure like account abstraction, bundlers, and paymasters and things like that. Again, it will all be type safe end to end. So we're using TypeScript across the stack to power a much nicer developer experience than, again, some of the alternatives out there. With that said, before we dive in, here are the kind of two call to actions. The demo is available here. So this is kind of what you get when you actually clone the repository. You can get a nice little preview of the features available in the stack that you're going to be cloning, as well as the documentation. If you do end up using this, you can actually view all of the different pieces of the puzzle in more detail on the docs. And all of this is open source. If you're interested in contributing to EVM Kit, the documentation, the template, the CLI, the homepage, all of it is 100% open source. And I would love to see any contributions if you are interested. With that said, the main call to action here is this CLI command here. So what you're going to do is you're going to copy this command and just go ahead and run that in your terminal. Once we paste this into the terminal here, it's going to go to our GitHub repository, take this template folder and just clone it into a new folder on your repository here. So basically, wherever you run this command, it's going to clone down the repository from GitHub, remove any of like the Git history and stuff like that. So you just have a fresh project, essentially with all of the boilerplate code set up for you. Once it is done, you can change directories into it and open it up in your text editor here. I'm going to be using VS Code in this video. I would recommend you do the same, because when you open it up, it's going to recommend you to install these extensions for Visual Studio Code that I have here. So we're going to be using things that help you out with the tools that you'll find in this particular project. I already have them all installed, so it's not going to ask me, but it's going to install things like working with Tailwind, working with CSS, working with .env files, boilerplate, all of these useful extensions that I've kind of gathered along the past couple of years of working with Next.js, TypeScript, Tailwind, and all of these kind of tools that you'll find in this project. What I recommend that you do is you open up a split terminal. So the way that you do that is you click terminal and new terminal, and we'll close this sidebar off here, and you just click this split icon. And the way that I like to use this project is on the left side, I'll CD into the contracts folder. So that is kind of the backend environment. And then on the front end, I'll change directories into the application. So on the left-hand side, we're dealing with our backend, our smart contracts. And on the right-hand side, we're working with the actual application, the user-facing stuff. So what we're going to do first is we're actually just going to install all of the dependencies that are available in both the contracts directory and the application directory. I'm going to be using yarn. You can choose to use npm, you can choose to use pnpm, whatever you prefer. I'm just going to be using yarn in this particular instance here. So basically, I'm just going to do yarn and yarn. So this is just going to install On the left-hand side, we're installing all of the smart contract dependencies, and on the right-hand side, we're installing all of the application dependencies. All of the stuff that I'll show you in this video is already documented in the documentation, so you can see in the getting started setup, we're just creating the project, installing the dependencies of the application and the contracts directory here. So if you prefer, you can go through the documentation. This is just kind of getting us set up. So if we go back to VS Code here, you can see this is okay, just can ignore that for now, but we have installed both of our application dependencies and our contract dependencies. So let's go ahead and clear both of these just so it looks a bit cleaner. And let's open up the contracts directory here to see kind of what we're working with. So as you clone the repository, you just get this very basic greeter.sol, which is a Solidity smart contract. So it has some internal state, a constructor, a read function, a write function, and the event getting emitted down here. So this is just boilerplate. Again, you can use this to build out your own smart contracts or interact with ones that you've already deployed from the application directory. So from the contract side of things, it comes with a couple of different components. So we have the actual smart contract itself here. I'll just quickly zoom in for you. So we have the smart contract itself, and we also have the test folder here. So we have a TypeScript suite of tests. We're using a hard hat here to run these tests. We have a simple test that says, okay, it should actually deploy the smart contract. We should be able to read and write the functions on our smart contract, and the state should update as we expect. So you could run these commands if we close off the right side of our terminal here and run these from the contracts directory. You can run yarn build, you can run yarn test, you can run yarn deploy. You can view all of these inside of the contracts directories package.json. So you can see here we have test, we have build, we have the command to run the actual local node. So if you want to deploy your smart contracts to a local node, that's also an option. You can then generate the types when we're working with the application directory, which we'll talk about as we deploy our smart contracts here. So what I'm going to do first is I'm going to run yarn build. So this is just to say, hey, is my smart contract project actually compiling? And this will use the thirdweb CLI to say, okay, what tooling are you using to build this smart contract application? Sorry, this smart contract. And in this instance, we're using hard hat. So it's basically going to say, okay, let's use hard hat to compile it and perform the compilation process to see if our Solidity is even valid and if we can actually build the smart contracts that are included in this project here. So once the thirdweb CLI is installed here, it's just going to do a quick little check for some updates. You can see now it's saying, okay, we've detected hard hat, and let's just go ahead and compile it. And you can see it is compiled successfully. There's no extensions, which we'll talk about a little bit as well. We can now run our test suite. So we'll say yarn test. This is going to go through all of the files that are in this test directory here. Again, all written in TypeScript to kind of improve that developer experience. You can see all of our tests are passing. And the point of this kind of backend setup is to say, hey, here's the basic foundation for creating your smart contracts, testing your smart contracts. And I'll show you next is how we'll deploy these smart contracts as well. So now we're happy with the build process. We're happy with the test process. Obviously, you'll want to change these smart contracts to be your own thing, or maybe you don't. Maybe you just want to test it out. Here's how you can actually deploy it. So there's no scripts to deploy it. You'll notice there are some generated files like the artifacts, the cache, the type chain types. We can just ignore those. What we're going to do is we're going to use thirdweb deploy to actually deploy our smart contract. And from a UI, we'll then pick, hey, which EVM compatible chain do I actually want to deploy these smart contracts to? And the way that we do that is just run yarn deploy. And again, under the hood, this is going to use the thirdweb CLI to say, okay, let's again quickly check for updates on the CLI. We'll compile, then we'll upload the outputted ABIs of the smart contract, which we can see in these kind of hidden directories here. So you can see here is the ABI for our smart contract. This is going to get sent to IPFS, and you can see here it puts out a link. If you're on Mac, this will open up automatically. On Windows, you just need to go ahead and click the actual link here. So if we open up this link, this is going to take you to a page where you can input the constructor arguments. So you can see in our smart contract here, we have a simple constructor where you need to provide one string argument, which is the initial greeting. That is what it's asking for in this deployment process here. So you can see if I just say hello world as the initial greeting of the smart contract, that is going to run this constructor logic here. The benefit to using thirdweb here is you don't need a script, you don't need your private key, you don't need to worry about any of this complexity when it comes to actually deploying. You can just connect your wallet with the, let's say, MetaMask or Coinbase wallet, or you can even use Gnosis Safe if you're working within a team from the thirdweb dashboard. Just quickly accept the terms and conditions, and now you're ready to deploy to any EVM compatible chain. So you can see we have Ethereum mainnet, we have Ethereum testnet, we have Polygon mainnet, Polygon Mumbai. If you want to deploy it for much cheaper, you can use the Polygon mainnet, Polygon Mumbai, all of these EVM compatible chains, as well as local hosts. So if you want to deploy to your own local blockchain, the remaining command that we haven't really showed here is this run node command. So you can actually just run yarn run node. This is going to kick off what is essentially a blockchain on your computer, and you'll be able to connect to that from the UI here. So if I click localhost, we'll be able to swap to the node that we're running here. But for me, I'm more interested in deploying to Polygon Mumbai, as I have a lot of Mumbai testnet and you can easily access those from the Mumbai faucet. So let's go ahead and click deploy now. This is going to deploy our smart contract to the Polygon Mumbai testnet. There's no private keys, no annoying scripts, and no risk of losing your funds, most importantly, because we're never exporting and placing our private key in plain text here. So this is going to deploy it, and then we'll do a gasless step to add it to the thirdweb dashboard so that we can come back and access this easily when we go to the thirdweb dashboard in the future. So that is the full kind of backend process. You're able to write your smart contracts, test them, build them, and now easily deploy them without any complex private key scripts or RPC connections. You don't need to sign up for any services. We've literally created our smart contract, tested it, built it, and deployed it in around 5 minutes here. So this is a really nice setup for you. And from here, you can actually interact with the functions directly from your smart contract, and this will call each of the functions that you write through the RPC that thirdweb provides, and then you'll be able to interact with, for example, Polygon or Mumbai testnet in our case. So that's the smart contract side of things. We've quickly been able to deploy our smart contracts, and we can use the dashboard here that gets provided to us. Let's say I want to actually update the set greeting to say hello Jared instead. We can execute that directly. Again, no private key, no scripts to interact with the smart contract. We're just using the connected wallet in a browser environment. So there's no risk here. That is the main benefit to the thirdweb deploy tool. So here you can actually kind of explore what's happening. You can view the read and write functions. You can view the events that get emitted. So once this transaction goes through, we should be able to see this event exactly there, the greeting change, block number, the information about the event, get some analytics, some settings, the sources of your smart contract. It automatically gets verified, which is another awesome feature of the thirdweb deploy tool. And what we can do now is we can jump into an application environment where we say, okay, I've deployed my smart contract, or maybe in your case, you want to interact with a smart contract that's already deployed, such as the Lens protocol smart contracts or OpenSea smart contracts. You want to build an application on top of some smart contract on some EVM compatible blockchain. And this is where the application comes into play. So you'll notice when you clone the project, there's kind of these 3 root folders. The first one is just the VS Code extensions and settings. You don't really need to worry too much about that. And then the other 2 is, again, the backend or the smart contracts, which, as the name suggests, is in the contracts directory. And the other half of this project is the application folder. So this is everything that the user sees, the application that you're going to be building on top of either the smart contracts that you deployed or smart contracts that somebody else deployed. And this goes a little more complex. So there's a couple different folders here rather than just the contracts and the test folder here. We have components, we have constant values, we have lib, we have pages, public, styles, and we'll get into what all of this means. But all we really need to do to actually set this up is plug and play our smart contract address into the project, or addresses if you're working with multiple, and the network that we deployed our smart contracts to. So what we're going to do is we're going to go into the const folder here, and you can see there are two files. There's a const chains.ts and a contracts.ts. And as the name suggests, you can see here is a little comment that says, here's where you define the blockchains you want to use for your application. So we have one chain for developing. So this is going to be on your local machine. Which chain do you want to use? When your application is actually deployed, then what blockchain do you want to use? So for example, we're saying, okay, in the local environment or a testing environment, I want to use the Polygon Mumbai testnet, which is the blockchain that we just deployed to. And then in a production environment, I want to use the actual Polygon mainnet. So for example, we could repeat the flow that we just created where we go through the thirdweb deploy flow to compile and deploy our smart contracts again onto a mainnet. So for us, we're just going to work with the Polygon Mumbai testnet right now because we're in a development environment and we're probably going to be iterating on our smart contract at this point in time. So what we need to do here is all you need to do is just import any of the available chains from the thirdweb dev/chains library here. You can see there's a very large number of them. You can actually define your own custom one, provide your own custom RPC. It's all documented on the thirdweb React SDK documentation. So you just import it and then set the development chain, set the production chain, and this is what gets exported. So it says, hey, are we in a development environment? Then use the development chain that you proposed. Otherwise, use the production chain that you set here as well. So basically, it just says, am I in a test environment? Use the development chain. Otherwise, use the production chain. So you can see here, we're already on the correct chain as we deployed to the Mumbai Polygon testnet. So that's that. And then the contracts.ts file is where we want to put our smart contracts. And this follows a similar flow. We have two values per smart contract. And then again, we use some conditional logic to say, am I in a dev environment? Use the dev smart contract address. Otherwise, use the production smart contract address. So this would be your Mumbai address in our case, and this would be your Polygon address in the production environment. So what I'm going to do here is I'm going to replace this value with the value that we just deployed. So this is our smart contract address. Let's go ahead and copy that, paste it into this value here. And that's it. We are now connected to our smart contract. So what we can do is we can go to the pages and we'll go to the home page here. You can see we have some demo components. So let's go ahead and actually just run this with a new terminal here. So from the application directory, let's run yarn dev, and this is going to load up localhost 3000. So let's open that up in our browser here. I'm going to go through each of these kind of 4 different parts of the project and show you what it means to have a wallet connection, contract interaction, user authentication, decentralized storage, and show you the different parts of the code. But at this point, you're actually just ready to use the complete repository, right? You can use any of the features available and use the documentation, which are available at docs.evmkit.com to add or remove any of the parts that you care or don't care about in the project. So the project that you clone or the application that you clone comes with these 4 different demonstration components that show you the different features available out of the box in the EVM Kit. And this is all really powered by thirdweb's suite of tools. So thirdweb React SDK, thirdweb Auth, thirdweb Storage, and thirdweb's UI components for the wallet connection aspect here. So the first demo component is wallet connection. Second is contract interaction. Third is user authentication, and fourth is decentralized storage. So we're just going to go through each of these individually, how to set them up, what they accomplish, and how you can use them in kind of real world applications. As we go through each of these, you'll learn more and more about each of the folders and files in the application directory. Again, this is all documented on the EVM Kit docs. So if you don't want to listen to me speak, you can actually just view this for yourself and explore as you choose to. So the first one I want to show you is this wallet connection component. And this is using thirdweb's UI components. So if we go to thirdweb.com and we go to the documentation here, you'll see in the UI component section, we have the connect wallet button. And essentially all you need to do is just provide this button what wallet connection options that you want to enable in your project. And the way that you do that is in the thirdweb provider supported wallets prop. So here you can see you provide an array of supported wallets, and this supports all different kinds of things, as I have previewed in a previous video talking about Wallet Connect buttons. So we have, for example, MetaMask Wallet, Coinbase Wallet, Wallet Connect, support for account abstraction, social logins, email wallets, all of this good stuff here available. And all you need to do is really just provide it inside of this array here. That's all there is to it. And in the application, you can see down in this demo component here is the thirdweb provider with supported wallets. It looks a little bit messy just because of the way that the demo is set out, where I allow you to choose which options you want in the button. And then all you need to do is just render the connect wallet button. So that is kind of the introduction to what this components folder is here. So within the application directory, you have components, and then demo, and you can see here are the 4 demo components that you see on that demonstration page when you load up localhost 3000. So you can see here, 1, 2, 3, 4 matches up to 1, 2, 3, 4. And then outside of the demo folder, we also have a couple different components. These are components created by the UI library that we're using, which is called shadcn/UI. I'm not sure if that's how you pronounce it. I'm sorry if I messed that up, but this is the library that we're using. It is built on top of Tailwind CSS and Radix UI. Again, I'm not sure if I'm saying these correctly, but that is what we're building on top of. So basically with this, it comes with a CLI as well. So what you can do with this CLI is you can run the add component command, and it will allow you to pick any of these available components that are all very well documented on the official documentation as well, and add them directly into your project here. So hopefully that covers the components directory. It's a place where your React components live. Some of them are just for demonstration purposes, like the contract interaction and wallet connection. Some of them come from the UI library that we're using, which also brings us to this utils file. This is just part of the initialization process with the UI library that we're using. So don't worry too much about the lib folder. So we've covered components, we've covered const, we've covered lib. We then have the pages directory, which we'll get into in a little bit as we explore these different sections in the demo components here. So we've covered wallet connection now. The second one that we kind of saw already was the contract interaction. But this gets a little interesting when it comes to giving you that type safety when you're actually reading and writing data from the smart contract. So what I mean by that is right now, we have never worked with any of the ABIs that our contract generated. So how do we know what functions are available, what arguments are available for those functions, and what the types of everything are, since we're using TypeScript across the stack here? And that brings me to the new command that we have available in the application directory here, which is this thirdweb generate command, or just yarn generate in our case. What this is going to do is it's going to detect any of the smart contract addresses throughout your application project. So for us, it's going to find this OX820420008 and pull down the ABIs for us and store them inside of the node modules folder, so that we don't need to worry about managing the latest versions or getting all of the types ourselves. And what the benefit of this is if we go to use either the use contract read function here or the use contract write, which, as the name suggests, allows you to read and write data to and from the smart contract, or from and to the smart contract, I should say. What we get here is right now, if we try and say, hey, which function do I want to read from the smart contract? It actually doesn't know what functions are available to call on the smart contract because it doesn't know the ABI. So from the application directory, if we open up a new terminal here, go to the application folder, we can run yarn generate. And this is going to say, hey, I'm going to look for any smart contract address throughout this project, and it's going to pull down the ABIs on the relevant networks that we've set up. So for us, it says we've pulled in one new contract, downloaded the ABIs, and cached the ABIs. For me, I like to give TypeScript a little kick just by restarting the TypeScript server. And this is going to now pick up the function names that are available on the smart contract in use contract read and use contract write. So you can see here, as soon as TypeScript restarted, it's now saying, hey, that's not a valid function. You can't call nothing. And now we get autocomplete when we try and call this. So you can see I can either use the greet or the set greeting function, which are the two functions that are available on the smart contract. So this is really, really awesome for getting type safety and making sure your code is actually going to work when you try and interact with the smart contracts when using these hooks or when using the UI components that ThirdWeb provides. So now we have this very nice type safety when reading and writing from and to our smart contract. This is the same here. You can see use contract write will allow us to write information to our smart contract from the connected wallet. We get that same type safety here. And also down here, when we try and call the actual function that we want to call, which in our case is to update the smart contract's greeting. As for the other two demo components, there is user authentication, which allows you to use the user's wallet address on the server side. So if we go to the demo here, we'll be able to see on the user authentication tab, we can ask the user to sign in following the sign in with Ethereum standard. This will ask them to sign a message, and we'll be able to prove that user's wallet address in a server-side environment. So for this, we're entering the pages directory and we go into the API route here. So what we're proving now is, hey, let's ask the user to sign a message so that we know they have a way of proving that they own this wallet address, right? Because they wouldn't be able to sign a message unless they had access to that wallet address. So that's what this API route is for. We then have a secret.ts API route, which I'll show you next. So once we sign in with this MetaMask pop-up here, we're going to be in a sign-in state. And now on the server side, or in a server-side API route in our Next.js setup here, we can ask on the server side, hey, does this user have access to this information? So you could do things like token gated websites or restricting access to information based on the user's balance or based on if they own an NFT. Really anything that you want to do on the server side with the user's wallet information. So this button here says, currently no user is signed in. I don't think that's correct. So maybe let's give it a quick refresh here. Sign in. And then if we get the address, there we go, wallet address from the server side function, which is what this logic is doing here. It's saying, hey, on the server side, get the user's wallet address if there is one. If we find a user on the server side, then we can return information based on that wallet address from the server. So what we're seeing here is saying, yes, there is a server signed in with the sign in with Ethereum standard, return a message to the front end, which is what we're seeing here. So we're seeing wallet address on the server side is 0x506, which is what I just signed in with. The fourth and final component that comes with the demo components here is the decentralized storage component. And there's really, again, no setup required here. You just are able to, out of the box, upload data to IPFS and download data via an IPFS gateway and render that on the UI. So what we'll demo here is at our localhost demo, we'll pick a file. So let's go upload a picture of me in Gandalf hair here. So you can see it is uploading to IPFS. So this is being sent to IPFS, and ThirdWeb provides the pinning services out of the box. That is going to be pinned in IPFS. Once it's uploaded, we're going to say, hey, let's get that IPFS hash, pull it through the ThirdWeb gateway to render information from IPFS. And regardless of what kind of file type it is, it's going to be rendered available here just with one of ThirdWeb's UI components, which is media renderer here. So this says, is this a video? Is this an audio file? Is this an image? Is this a 3D model? Is this HTML? And renders it onto the UI for you here. So again, no setup required, and there's no real other pages or files that we need to touch here. So the remaining two folders that we haven't talked about are the public folder, which if you know about Next.js is just where you store things like your favicon or any images that you want to use throughout the application. And then styles, we're just defining the global styles that we want to use for Tailwind CSS. So these are the values that get pulled for both Tailwind CSS as well as the UI library that we're using. You can feel free to customize these as you choose. And I believe that the UI library creator is adding more support for different color schemes and themes as he builds out the project. So that is pretty much everything that comes with the application directory. You have all of the pieces of the puzzle that you would expect from a full stack Web3 application. You have connecting to users' wallets, connecting to smart contracts that you created or somebody else created via the RPCs provided from the thirdweb chains package. So you get these RPCs out of the box. You can read data from, you can write data to smart contracts with complete type safety across the stack. All of the interactions come from the connected wallet as well, which is an awesome feature. If you want to kind of build out a more complicated application, you can use user authentication and involve the server-side aspects that Next.js allows you to bring into your applications. And then the fourth and final piece is the off-chain storage. So not everything you want is going to be available on the blockchain and not suitable to be stored on the blockchain. So sometimes you want to use things like IPFS to store that information. So that is the demo. And again, all of this is completely open source. So feel free to jump into the GitHub, make any changes, issues, requests, contribute to any of the things that I've showed you today. Let me know in the comments what you think. Will you adopt this into your next Web3 project? Will you give it a try? Would love to hear any feedback that you have on this little project that I created. So with that said, thank you very much for watching. Thank you for making it this far. If you enjoyed it, please remember to hit the like button. It does help me out in the algorithm, and subscribe to the channel for more Web3 videos coming soon.